Question number 17 says low-dose aspirin contains 81 milligrams of the ingredient acetylsalicylic acid, or ASA, per tablet, and it's used to regulate and reduce heart attack risk associated with high blood pressure. So it says given a tolerance of 20%. Now tolerance means that we are looking for 20% from the ideal, which is 81 milligrams. So solve an absolute value equation for the maximum amount of ASA. So one way we can do this is we could do this as a percentage problem, or we can do this as just calculate the 20% tolerance of 16.2 milligrams and solve it that way. So we'll do that first. So the amount of acetylsalicylic acid in the tablet we'll call X, and the difference from the ideal of 81 milligrams, we need that to be less than the tolerance level, which is 16.2 milligrams. And then we solve to the absolute value equation for this. So we need the X minus 8 is less than the 16.2, and the negative X plus 81 is going to be less than or equal to the 16.2 tolerance level. So we have a minimum value or maximum value here. X has to be less than 97.2 milligrams. And on this side, we're going to end up with 81 minus 16.2. So I'm going to end up with 64.8 milligrams. And then I'm going to add X to both sides. So put X on this side. So X has to be greater than the 64.8. So we know that the minimum value is going to be 64.8 and the maximum value is going to be 97.2. Okay, so we could set this up as an equation of the actual milligrams. We could also set this up as a percentage problem. We could just say that the difference divided by 81, the total, has to be less than or equal to the 20%, and then we end up with the exact same equation after we do our first step here. Part B says, which limit might the drug company tend to lean towards? Probably going to be the lower one because it costs them less when they do that.